This slide presents the two moderately complex examples of finding first the median, described at the top of the slide, and then moving averages, described towards the middle, using temporary tables and subqueries rather than the more advanced windowing functions, which are not available in MySQL, but are shown down at the bottom of the slide, but will be briefly reviewed with SQL Server in data warehousing portion of this class. We start by presenting the median calculation using employee salaries by going directly with the definition of the median as a center point in the sorted list of numbers. If the number of observations is odd, then the median is a unique center point of the ordered list. For even number of observations, the median is defined as an average between the two center points. First, we'll create a temporary table called EMP underscore salary with auto-incremented row numbers 1, 2, 3, and so forth, as well as the salary column as shown partly in the where is it? Partly in the MySQL7 underscore 05 underscore number towards the top of the code. Okay, then using the insert into statement, we'll insert the sorted salary column from employee table into EMP salary table. Okay, we'll open it to verify that auto increment worked by creating a position slash index list of salaries from 1 through 97, which is an odd number. Okay, and we're going to verify the salaries are in the ascending order. Then we're going to calculate, or really just find, the position of the median by adding 97 and 1 to get 98, dividing by 2 to get 49, and then scrolling down to know that the median salary is 33,000. So let's do all this by copying the first set of statements here, dropping the table if exists, creating employee salary, and then inserting the numbers. Okay. All right, and then we'll go to EMP salary and notice that the number is 1 through 97 and the salaries are sorted, right? And the median salary is, what was it, 98, 1 plus 97 divided by 2, right? Which is 49. So it's the $33,000 as just mentioned. Okay, I'm going to clean this up a little bit, switch back to the code. Now, we essentially implement the logic of the median query. We start by first finding the total number of observations, which we know is 97. This can be done in a few different ways, either with the count function or using max on row number column. The subquery will result again in a single row, single column with number 97 in it. Okay, so we'll start by placing that somewhere here. Okay, in between this select query, and we'll say select max row number as max row number. Okay, and testing it that it, verifying that it gets us 97 should be straightforward. Maybe not. Because we don't have the from. From EMP salary as max. Okay, because we don't have from EMP salary. Okay, trying to hurry never works out. 97. Okay, going back to the code. Now, what we want to do next is create a cross product of the EMP salary table with this single row and select all the columns to see the effect, which is just a replica of the entire salary table with an additional column that has this number 97 repeated however many times, 97 times, I guess, right? So we're going to we're going to do that here by sort of folding the select statement towards the top, right? Okay, right here. One more. Okay. selecting everything from a cross product of EMP salary with this single row, right? Nowhere clause yet. Nowhere clause yet. Okay, does that work? Yes. All right, so it's the entire, EMP salary table with number 97 next to it. Okay, now the where clause, right? The trickiest part of here is to use the center point or points calculation in the where clause right here. Okay, to find that either unique row that I've shown here, right? The unique row 49 right here. Okay, or in case of the even numbers, there's going to be two subsequent rows, 49 and 50, if you have 98 observations. Okay, we'll continue by simply assuming that the simpler case is true, which is the odd number observation. In that case, the number of rows plus 1 divided by 2, as we did several times in this case, 97 plus 1 divided by 2 is 49, is the location of the median. Right? This will result in a single row, okay, with the median salary 33, as was already shown a few times. Okay, so we're going to put the where clause here. Okay, the name of this entire table that I just, this table is EM. Okay, EM dot max row number, which is the third column. That all has all those 97s. Okay, plus 1 is 98, divided by 2 is 49. Okay, if that matches one of the rows, okay, if this matches one of the rows in es.row number, right? If this matches one of these rows here, right, which it will, 49, then we got ourselves a median row isolated. Okay, so let's save that and see if that works. There she is. Okay, so now folding this into an outer query here that's going to simply average this single number. It doesn't really do anything for us in this example, because the averaging single number is just going to repeat the 33,000 back to us. So before we continue, what we'll do, we'll insert into the employee table another salary, another employee with another salary. So employee number 98 with a salary of 43,000 must go into the employee table, cannot go directly into the EMP salary table because the outer increment is not necessarily going to be 98. Okay, so here, run, look at the employee table and verify it has 98, right? We don't care about any of the other information rather than just the salary. Now what we need to do is go back here and we have to drop and recreate and reinsert. I'm going to run this SQL again. Okay, I'm going to copy that. It's going to drop the table first, recreate it, okay, and then reinsert it, and that's going to guarantee that EMP salary has, for the last one, 98 rather than some random auto incremented number. And now it's an odd number of observations. We have to find the following record set that consists of the 49th and 50th row, and then we got to average the salary to get 33,500 over here. Okay, so the way we're going to do that is we're going to go back to the where clause, and we're going to say or, okay, or es dot row number, right? That's the first column, the row number column. Not of this table. It's going to be of that table that's recreated with 90, with 98s now repeated and so forth, and that's all fine. In, okay, em dot max and max row and o divided by 2, because I know it's divisible by 2. I know that because I know it's an even number. Okay, comma, but it's not just 98 divided by 249. It is 98 divided by 249 plus 1 is 50. Okay, So if I run this select statement, I should be getting just those two rows. Okay, and here they are. Okay, and then folding this into the outer query, simply copying it, pasting it here. I hope all the parentheses are where they're supposed to be. Let's save that, copy, paste, um, and run to get that 33,500 as advertised. Okay, and before continuing further, it's important to delete that employee, that fictitious employee. Not that they're all fictitious, but because we're gonna need employee table further on. Okay, so we're going to clear this stuff out. Make sure the code is saved. Switch back to the presentation and pause.